For microfluidics, if you can imagine an electric printed circuit board, but instead of those wires, you've got fluidic tracks, less than a millimetre in dimension, with very small volumes of fluid going through. An engineer designed a system and you have to test it. Now, when you get up to large-scale manufacturing, you're looking at injection moulding machines and bonding things together and producing thousands and thousands. When you're wanting to test prototypes, you only want to make 10 or maybe 100. The traditional processes for making those can take time. You can get injection moulded parts within 4 or 5 weeks if you know where to go, but you're going to be looking at thousands and thousands of pounds invested into tooling, which is a lot to commit to a design that you don't know if it's going to work or not. Using fairly conventional 3D printers and fairly conventional materials, but in a slightly different way, we've developed a technique where we can produce a microfluidic chip, a prototype, in less than an hour. We can go from a conversation, a concept sketch, a CAD model, produce a chip to being tested on a lab bench within less than 24 hours. And you can go through multiple design iterations for very little cost in a remarkably short time, which allows you to get to that final design so much quicker, which then you can commit to your large-scale manufacturing techniques. A lot of the work we're looking at the moment is working with biotech companies who are developing COVID detection systems. I think everybody in the world is now familiar with the term PCR, point-of-care testing. That's what we're doing. I think one of the aspects that we can really help is that not only are we producing these prototype parts, we have a web shop set up so anybody can go on there and buy a mixer, a serpentine for heating or anything like that. Ultimately, I guess we're looking for the opportunity to talk to other biotech startups who are trying to grow there. They're trying to develop a product based on a need, based on some research. And that's where I'd like to think we can grow with them, form partnerships and collaborations.